Roboflow is a set of tools for building production-ready computer vision workflows fast. Better data sets, seamless model training, easier deployment. Let's say you're a cashier and people often pay in your store in individual coins. We want to build a model that's able to identify each of those individual coins, sum them up, and tell us how much someone has paid. Now, while in this problem we're counting coins, we could be counting a variety of things. Cars in our parking lot, taking inventory in our back rooms. Maybe we're even a manufacturer and we're looking for defects on the coins that we're producing. At any rate, everything gets started with a workspace and a project. Let's dive in. I've already created a workspace here called Coin Counting Inc. I also collected some images earlier where I snapped some photos of these coins on my counter. I'll be creating an object detection problem because I only need to know the individual coins and what they are to sum up their value. Roboflow supports classification and segmentation as well. I'll be detecting coins and then building a counter. Here is where I can upload my images. Note that Roboflow supports videos and images alike. So if I drop in a video, it breaks it into individual frames for me. I'll also drop in all of these images that I already have prepared. Notably, these images aren't annotated, but I did annotate a couple of them in a different tool earlier. Roboflow supports over 34 annotation import formats. So if you already have annotated images from elsewhere, you should add the annotations and Roboflow will automatically match them up. I'll save and continue and create a train test split for later when we're prepping our model. Now, I uploaded my images using the web interface, but I could have uploaded them using an API. I could also use open images or open source datasets to add here. Now I'm ready to annotate. I'm only going to annotate alone, so I'll assign all the images to myself. For annotation, I jump in to this individual image and I just start drawing boxes because I'm doing an object detection problem. I'll create here a class for quarter. Here I see a nickel. I see another nickel over here, so I'll add another box there. This is a dime, so I'll use the dime class. Here there's another dime, a dime here, and a dirty penny, but nonetheless a penny. And over here a quarter. I only have a small number of images here, but it's good enough to get started. I'll use a little movie magic to fast forward. Let's pretend I was labeling for instant segmentation instead of object detection, so I needed to create polygons. I could use the Smart Polygon tool to draw a box and then have that box snap to the shape. I can click the areas that I don't want the polygon to include, so it gets a little bit more fine-tuned. And voila, I have a much nicer polygon label. Since I'm only doing object detection, I'll continue with bounding boxes. Because I've already labeled a lot of these images and trained a model, I can use model-assisted labeling to label things for me. So to turn that on, I'll turn on Label Assist. I'll label with my money counter model that I already have. It asks which classes I want to use, and then it makes guesses based on the prior model that I might have already trained. And it looks like here it nailed it. Nickel, nickel, dime, 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 dime. So I'll jump to the next image. And there it's doing a really good job of filling these in. Here it looks like this was actually a quarter. And this is how I'm going to finish labeling the rest of the images. Okay, great. I've annotated all of my images. I'll go ahead and add all of these to my dataset. When I generate a dataset version, I can do things like add preprocessing and augmentation steps. I'll add a few steps that I think will increase the variety of images that I think the model might encounter in the real world, like flipped coins. Maybe the coins are sometimes closer or further away. Maybe the hue may vary. Sometimes the exposure could even be brighter or darker. That looks pretty good. Now I can generate a dataset version. For a quick first check, I'll just kick off a training job. I'll kick off from the Microsoft Cocoa checkpoint so the training is faster and easier. If I wanted to train my own architecture, I could get the data in the format that I need. For example, maybe YOLO v5. And here, Roboflow will automatically create the download code that I need. I could then go to use Roboflow's model library. While the model is training, I get a training graph to see roughly if the model is learning the task. Let me show you another model that's out of the oven and already done baking. It did a pretty good job. It got 77.6% map, which is a good starting point. When a model finishes training in Roboflow, we can easily try out that model by clicking the Deploy tab. We have examples available to us that our model has never seen before. In fact, I have an example image that the model has never seen before here on my local computer, and I can drop this in and see if the model finds those coins. And indeed it does. With the Deploy tab, I can also get ready to use my model in a wide array. I could use it on a webcam, I could use it in real time, I could use it via API, I could deploy it to a Jetson, I could use it on an iOS, I could use it in my own Docker container and deploy that inside my own environment offline. For this example, I'll use the hosted API so I can make an API call with an example image and get back the responses. With those responses, I'll then see which coins are present and do summing. Let's get started with our script. So I'll go ahead and copy this Python. Of course, you want to keep your API key secret, and I'll invalidate mine. I'll drop this in. I'll show you that I can load in my example image name here, and it'll print out the predictions. And you'll see below, I get all of the responses in this nice JSON. So for pred in response inside the predictions dictionary, I will print the pred class. This will print out all the example classes that the model sees in this image. At 40% confidence, it does see each of those classes. I like to bump this up to 70 just to be a little bit more certain, though it depends on the problem that you're solving. For each of those preds, we actually want to do logic. If it's a quarter, add 25 cents. If it's a dime, add 10 cents. I've already written that logic, so I'm going to just copy paste that directly into my script. Sum them up and print out the result. And sure enough, the sum is 68%. Now, what's also exciting is I can use this model immediately on my webcam. I'll take my phone here and I'll open up the webcam format and let me show you this work in real time over top of my coins. So there you have it. Good luck building.